Hello everyone, welcome back to another session by K21 Academy. Today our expert trainer will be talking about domain 2, that is run experiments and train models. So let's get into the video.
So in domain 2, we have these, all right? So the domain 2 is basically about running experiments and training models. Okay, so let's go ahead and see them quickly. So first to start with, Azure Machine Learning Designer. And as we know, the Machine Learning Designer enables you to create your entire machine learning workflow with a visual aid, all right? So just by clicking, dragging, and dropping, you are able to create the entire machine learning workload, all the phases, okay? So for example, you can start getting the data and then apply some data transformation, whether be it cleaning the data or doing the normalization to the data or feature transformation and so on. Once we do that, then we do what we call selecting the algorithms, what algorithms we want to train them on. So as you see here, you have the entire interface here that allows you to pick up any of those components that you need to add as part of the flow here, where you have your canvas here to create all the steps, right? So you can create that and create a pipeline here. So the standard workflow looks something like this, okay? So where you are working with data set, preparing the data, then splitting the data, all right, be it your cross-validation or training and testing data. After you split, you also select what algorithm that you want to choose, all right? So you can select the algorithm explicitly. If you don't want to select this or do this, then you go for something called automated ML. We will talk about that in a bit. So now after you select the algorithm, then you train your model, then you capture the metrics, okay, the score of how your model has been trained. Then you evaluate your model, okay, based on the metrics, whether it is accuracy or based on your ROC curve, all right, or based on precision or recall, whatever metrics you set out to check, all right? Or if it is a regression type of problem, then you might evaluate the mean squared error or mean absolute error, okay? So those are the metrics we use. Again, you need to have a clarity on what are the metrics we use for regression problem, what are the metrics that we use for classification problem when we want to evaluate the model's performance, all right? So that's, of course, a side point, but that's something you can easily explore and keep in mind, all right? Let's take a question here. We have created a pipeline that includes multiple modules to define a data flow and train a model. Now you want to run the pipeline. What must you do first? All right, so the correct answer is we create the training cluster and select the compute target for the pipeline first. Okay, let's go to run your model training scripts. Okay, when we want to run, okay, to keep things short here, most of the time you will, if you're familiar or if you have a better command in writing codes and implementing things, then you could use the Azure ML SDK to write your code. And as you know, once we have provisioned our compute instance, you can launch all of these SDK, okay? So be it your Jupyter or RStudio, okay? So one of the things we have used as part of our lab throughout the session is our Jupyter Notebook, okay? So we have the files and we can run them and see the results here. So when we are using an experiment to train a model, our script should say the trained models in the output folder. So to prepare an experiment that trains a model, a script like this is created and saved in the folder. So I'm sure you can recall all the hands-on where we have to define all the configuration details about training that model inside our training script.python file, okay? And then once we have done that, then to run the script, we create a script run config wherein we take the reference to the training script.python file to run our experiments. Okay, so it looks something like this. Okay, so we have our training.python file, which is already predefined earlier, and then we are just calling them inside our script run config before we run that file. All right. So as simple as that. Again, so these are the files where you can take note of how to bring in the dependencies or libraries into your Python file. All right. So for example, here you are bringing the dependencies from Conda for your Azure ML. Sometimes you will bring it from scikit-learn, or sometimes you will bring it from matplotlib if you're particularly going to visualize your data as part of your script. All right. So depending on what you intend to do inside your code. So yeah, it is creating the folder. It is for the same simple reason that you are able to keep the relevant files inside a relevant folder. So it is more of clarity and kind of best practice purpose. Yeah. Okay. So once we, depending on the type of workload that you're going to do or the task that you're going to do, in that coding file, you will install or you will bring in or import the respective dependencies and libraries. All right. So let's quickly take a sample question here. You want to run a script as an experiment. You have already created a run configuration object to define the Python runtime context for the experiment. What other object should you create to associate the script with the runtime context? All right. Okay. So just as discussed, we will use the script run config object. So generate metrics from an experiment run. All right. So every time after we have trained our model, all right, everything pertaining to that particular training, you are able to capture them and store them in your log files. Okay, and the logs can help you to diagnose errors and warnings or track performance metrics like parameters or model performance, right? So when you use the machine learning flow logger to log metrics, it will record everything, including what metrics that you're going to use, okay, your experiment name, run, all right, and tracking, and the ID, the run ID, all right. So all of this, you will be able to see it as an output for this code when it runs, or you can also go ahead inside our workspace and click under the experiments and look for a particular run ID and look for the output and log folder, and inside there also you can see all of the outcome. All right. So you know where to go and get this checked. Yeah. So you can also view the metrics of your trained model using this method called run.getMetrics. Okay. So let's take a question. You plan to configure logging for an experiment that explores data associated with gender distribution within organizations across the world. The experiment must draw a box plot of genders by country. You need to use the appropriate logging method to render the plot for the experiment run object. Which run object method should you use? Okay, so the keyword here is box plot. So that is one of the type of visualizations that you can see, and most of the time this is used to visualize and see if there are any outliers or anomalies inside your data set. Okay, so we will use log image. Okay, so because that is what is, you're going to get that as an image. All right, your box plot is going to be not a text or number, rather it's going to be an image because it's a visual. All right. So then one of the most celebrated feature in our workspace, okay, which is using the automated ML. All right. If you really want to start working with this Azure ML, if you know this feature and the designer, you can comfortably start your project and work with that. all right? Even if you don't know a single line of code, you don't know what dependencies, libraries you need to bring in, what are the config files and metrics you need to evaluate. Let's say at the beginner stage, if you don't want to get yourself entangled in all of these different jargons and techniques, the single most feature you can use to get your project still done is by using the automated ML feature. All right. What is something that we do here? As simply put, you as a data scientist, you are only bringing in the data that needs to be trained on. All right. The rest, you don't have to worry about anything. But again, bringing the data is not as easy, right? You need to know what are the features that are relevant to do the prediction in this particular case. So you need to select, maybe do the feature selection, then maybe do the quality, improving the quality of your data and feature transformation. Let's say you do all that. Once you have data ready, then consider the job is done. Why? Because the rest of the things is going to be taken care by your automated ML. What are the rest of the things? The rest of the things we need to specify, right? Let's say if you don't use automated ML, what are the few things we will have to do? We will have to select what algorithm to run on, and then we need to capture the outcome of the train model, which is usually your score model or the metrics, all right? Then you will evaluate the model, okay? So again, you will do this for a few iterations, okay? So the next time when you run, you might use a different algorithm, all right? You might use a different set of hyperparameters to tune them. So you will do a lot of these things, okay? So in a way, you will be running few experiments and then compare the outcome from these few experiments to see which is the best performing model, okay? So all this will take time and you need to consistently put your mind to select all of them. Now with automated ML, all of that is saved. You don't have to worry about them. Why? Once you bring in the data, the rest all is going to be managed by automated ML. So what automated ML does? It will basically select the most suitable algorithms for that particular type of problem or what you want to predict. And then it will run and it will capture the metrics and it will compare the metrics. Basically, it will evaluate the performance of the model and it will propose to you which is the best performing model. Okay. So all that you do is you bring in the data, then you take the best performing model and you go ahead and deploy them. The rest in between jobs is done by your automated ML feature. All right. So as you see here, select the data set, give your data, then you set the few configuration. What type of configuration? What type of prediction you are going to have, whether it is classification, regression, or clustering, okay? Not clustering, here we have time series forecasting. So you select which one it is, and then that's all, the rest is done. You will have to just find the best model, and then, the best model is already found for you. You just take time, you take it to go ahead and deploy that, right? So that's straightforward and that's easy, this, all right, using the automated ML feature. So one of the most important configuration setting is the metric by which model performance should be evaluated, okay? So that is an important decision that you have to make. If you're doing classification, again, if you recall, we discussed about the confusion matrix. You have accuracy, you have precision, you have recall, you have F1 score, you have AUC weighted, you have ROC. Okay, so there are many different metrics that you can capture. Again, which one is depending on what you're trying to predict. Okay, so let's say if you're looking at binary classification, okay, whether a particular person should be given a loan or not, whether a particular patient record, looking at the record, we are predicting whether the patient will have cancer or not. Okay, so these are all very crucial prediction that we are making. Okay, and again, depending on the use case here, the kind of metrics that you choose to evaluate also differs. Okay, so that's something you need to suggest. Okay, for this model, use this metric and use this metric to evaluate the model's performance. Right, so that again, you need to really get familiar with the metrics, kind of metrics, what each of them represent, what is the meaning of them. Then you have an idea which one to propose as you use the Azure ML. All right. So let's take a sample question. Let's go on. Let's see this question. You want to use automated ML to find the model with the best AUC weighted metric. Which parameter of the auto ML config object should you set? Okay, it is C. All right, so that was an obvious answer. One of the approach here is you can eliminate the ones that are not relevant, then you will naturally land on the correct one. Okay, good. Let's talk about hyperparameter. All right, so hyperparameter tuning. All right, so here we talk about regularization as one of the hyperparameters. So hyperparameters are again something that you can set that is going to affect how your model is going to be trained. Okay. For example, the number of iteration, okay, you need to train your model on, or the learning rate. Okay, the learning rate is specifically used in the deep learning environment, but these are some of the examples of hyperparameters. Okay, so these are not the data or information that exist as part of your what do you call data set. Okay, so these are variables that you set and that affects your training environment. For example, you're going to run a machine. Okay, you're going to specify maybe the speed at which maybe the motor should run, for example. Okay, so you set it up in a particular speed. That setting up is up to you, and you know how best, what is the best or optimal value that can bring you the best performance. So things like that here, again, we don't know what is the right value. So that is why we run experiments sometime. So we keep changing the value of hyperparameter for each run, and therefore we are able to see at the end which hyperparameter has really contributed to the best or optimal model training. Okay, so again, to do this, if you have few hyperparameters, then you have a hyperparameter sampling method. And I think part of the lab, we have used something called grid sampling. It will take the combination of all the hyperparameters, okay, and then run for each combination, all right? So let's say if you have learning rate and if you have another, let's say regularization. So if you have 2 learning rate value and then you have 3 regularization rate, it is going to use the combination for each and then come up with that many number of iteration or experiments. Okay. Early termination policy is again something, it is not mandatory for you to specify, but it is good to specify as it can save your compute resources from running unnecessarily. If you have an idea that, let's say, if you're going to run the 4th run as part of the experiments, you can set some values to see if we are going to get this in the beginning. We are going to stop and exit because compared to the previous run, we know that if it is going to start from this and going to go ahead, it is not going to produce or make any difference. So it's better to stop and exit. All right. So things like that, again, there are some settings you can specify, but the basic concept behind here is that if you set out to run a particular experiment and if you want to define the exit policy, all right, based on certain values or outcome of that, then you can set that. All right, so let's take a sample question quickly. Okay, so it will be B. Okay, so I think I have mentioned this. So it's going to take every possible combination of your value from two hyperparameter and then run it that many number of times. Okay? So we have discussed this, and in the lab we have used grid sampling as well, if you can recall.
So guys, this was our expert, and if in case you missed upon anything and you could not understand any of the technical keywords, then we have something really special for you. We have our free class on Microsoft Azure Data Scientist Certification demo along with some question and answers, that is DP-100. And if you want to gain access to this free course, then you just have to log on to k21academy.com/DP10002. Under this course, you'll be learning about why to learn Azure Cloud and some of the amazing market trends for machine learning. You'll be getting a certification roadmap. You'll be working on real life demos as to how to create ML workspace in Azure. You'll be learning about training and deploying a classification model in Azure and machine learning and what not. So, if you really want to enroll for this free course, then all you have to do is just log on to k21academy.com/DP10002. After that, you'll be seeing a page like this. You just have to click on book your free seat now and select your event date according to your availability. Enter your name, your email address, your phone number, and click on Yes, Save My Seat. Moving ahead, you'll be getting this kind of page where you'll be seeing this kind of URL on your extreme right. Save that URL, add it to your calendars, and I'll see you in the free class. Till then, take care and keep learning.